What if I told you there's a framework that explains how every single message you send online gets delivered? From emails to TikTok, it all follows the same blueprint. Hey there. Today, I'm breaking down the OSI model, the 7-layer framework that's not just crucial for your Network Plus exam, but will completely change how you understand networking problems. By the end of this video, you'll have a mental model that makes troubleshooting network issues almost intuitive. Plus, I'll reveal the one layer that causes more confusion on the Network Plus exam than all the others combined. The OSI, or Open Systems Interconnection model, isn't just another boring concept to memorize. It's like having X-ray vision into how networks actually work. Created back in the late 1970s, the OSI model splits network communications into 7 distinct layers. Each layer has a specific job and interacts only with the layers directly above and below it. This modular approach is what makes modern networking possible. Think of it like sending a package internationally. You write a letter, your data, put it in an envelope with an address, adding headers, take it to the post office, transmission. It goes through various sorting facilities and carriers, routing, finally, arrives at its destination where someone opens it, decoding. But in networking, this all happens billions of times every second worldwide. You might be wondering, why should I care about some theoretical model? These 3 big reasons. Standardization. It creates a common language for networking professionals. Troubleshooting. It helps you isolate exactly where problems are occurring. Network plus exam success. It's one of the most heavily tested concepts. This model gives you a systematic approach to understanding everything from why your Wi-Fi won't connect to how global internet traffic is managed. Let's start at the top with layer 7, the application layer. Despite its name, this isn't where your actual applications like Chrome or Outlook live. Instead, it's where those applications interface with the networking processes. The application layer provides services directly to the end user's applications, identifying communication partners, determining resource availability, and synchronizing communication. Here's an example. When you open your web browser and type www.google.com, the application layer is what recognizes this as a web address and knows to use HTTP or HTTPS to retrieve the web page. Here are some common protocols: HTTP and HTTPS. These are for web browsing. SMTP, POP3, and IMAP for email transfer. FTP and SFTP for file transfers. DNS, domain name resolution, and SNMP, network management. But here's some troubleshooting. Issues at this layer typically manifest as application-specific problems. I can't access this website. My email won't send. File transfers keep failing. The key question to ask, is it just one application having problems, or all of them? If it's just one, you're likely dealing with an application layer issue. Moving down, we reach layer 6, the presentation layer. This layer acts as the network's translator, handling data formatting, encryption, and compression. Its main responsibilities: converting data between application and network formats, encrypting and decrypting data, compressing and decompressing data. When you upload a photo to Instagram, the presentation layer compresses the image to make it smaller and ensures it's in a format that can be transmitted efficiently. Some common protocols and standards: SSL and TLS, encryption for securing web browsing; JPEG, GIF, PNG, image formats; MPEG and MP4 for video; ASCII, Unicode; text encoding. Presentation layers often appear as garbled text or characters, corrupted images or files, certificate errors when accessing secure sites. When you see invalid format or encryption-related errors, think presentation layer. Good old layer 5, the session layer. Manages the ongoing conversations or sessions between devices. It establishes, maintains, and terminates these connections, ensuring that data exchange happens in an orderly fashion. Its key functions: setting up connections between applications, maintaining those connections, properly closing connections when done, adding checkpoints for long data transfers. When you're on a Zoom call, the session layer keeps your connection to the meeting intact, even as data continuously flows back and forth. If you temporarily lose internet, the session layer can often help re-establish the connection without you having to rejoin the meeting. Some common protocols are NetBIOS, Network Basic Input and Output System; RPC, Remote Procedure Call; SIP, Session Initiation Protocol for VoIP; SQL, Structured Query Language for database sessions. Session layer problems typically manifest as disconnections during ongoing communications, inability to establish connections to services, applications freezing during data transfer, and session timeout errors. If you can connect but keep getting disconnected, suspect a session layer issue. Now, we're getting to the core of networking with layer 4, the transport layer. This layer is responsible for end-to-end communication, ensuring complete data transfer. It handles segmenting data into smaller chunks, flow control, preventing sender from overwhelming receiver, error recovery through retransmission, delivering data to the correct application through ports. When streaming a Netflix movie, the transport layer ensures all the video data packets arrive in order and without errors. If packets are lost, TCP, Transmission Control Protocol, would request retransmission to avoid video glitches. Some common protocols: TCP, Transmission Control Protocol, reliable, connection-oriented, that three-way handshake; UDP, User Datagram Protocol, faster, connectionless, and just goes with best effort; SCTP, Stream Control Transmission Protocol, and their ports: HTTP, port 80, HTTPS, port 443, FTP, or File Transfer Protocol, port 21, and it goes on from there. So some common troubleshooting: applications timing out, incomplete data transfers, very slow performance, and port connectivity issues. The key question: can you connect to the resource, but experience issues with the quality or completeness of the data? That's often a transport layer problem. Layer 3, the network layer. This is where the magic of routing happens. This layer determines the best path for data to travel across multiple networks to reach its destination. Its responsibilities include logical addressing, route determination between networks, packet forwarding, fragmentation and reassembly of packets. When you send an email to someone in another country, the network layer determines how that data will hop across dozens of different networks to reach its destination on the other side of the world. Some common protocols is IPv4 and IPv6, ICMP, Internet Control Message Protocol, OSPF, EIGRP, BGP, which are routing protocols, and IPsec, IP security. Network layer problems manifest as inability to reach remote networks, request timeout in ping tests, high latency, and routing loops. Tools like Traceroute specifically help diagnose Layer 3 issues by showing the path packets take through different networks. Next up is Layer 2, the data link layer. This layer handles node-to-node communication within a single network and is responsible for detecting and potentially correcting errors that may occur at the physical layer. But first, the data link layer provides physical addressing, MAC addresses, detects and potentially corrects errors, controls access to the physical medium, defines how devices on the same network communicate. It's commonly divided into two sublayers: Logical Link Control, LLC, which provides error checking and frame synchronization, and also Media Access Control, or MAC, controlling how devices access the network medium. When your laptop communicates with your home router, The data link layer uses MAC addresses to ensure the data gets to the correct physical device on your local network. Here are some common protocols. Ethernet, the standard for wired local networks. Wi-Fi, the 802.11s, the wireless network standards. ARP, Address Resolution Protocol. PPP, Point-to-Point Protocol. MPLS, Multi-Protocol Label Switching. Data link layers issues, they typically include devices on the same network that can't see each other, excessive collisions in network traffic, duplicate MAC address conflicts, NIC or network interface card failures. If two devices on the same network can't communicate, look at Layer 2 first. Finally, we reach Layer 1, the physical layer. This is the only layer you can actually see and touch. It deals with the physical connection between devices and the transmission of raw bit streams. The physical layer defines hardware specifications, encoding and signaling, transmission and reception of raw data, physical network topology. When you plug an Ethernet cable into your computer, you're interacting with the physical layer. The electrical signals that travel across the copper wires or the light pulses in fiber optic cables are all part of this layer. Some common components and standards are cables, Ethernet, fiber optic, coaxial, hardware, which is hubs, repeaters, network interface cards, your connectors, RJ45 or fiber connectors, signals, electrical, light, or radio waves, and also encoding. Manchester encoding, NRZ, you get the picture. So, troubleshooting at Layer 1. Physical layer issues are often the easiest to identify. No link lights on network devices, cable damage, interface failures, and signal interference. Always check the physical layer first. The famous IT support question, is it plugged in, addresses this layer. Now, as promised, let's talk about the layer that causes the most confusion on the Network Plus exam. Layer 4, the transport, and the Layer 3, network. Students often mix up what happens at these two layers because they're both involved in getting data from one point to another. Here's how to keep them straight. Layer 3, or the network layer, deals with getting data from one network to another using IP addresses and routing. Now, Layer 4 ensures that data gets to the correct application on the destination device using ports and handles reliable delivery. To say it another way, Network Layer 3 gets data to the right computer. Transport Layer 4 gets it to the right application on that computer. The OSI model isn't just theoretical. It's a practical troubleshooting tool. Network professionals use a bottom-up or top-down approach based on this model. Bottom-up troubleshooting. Start at the physical layer and work your way up. Physical layer, you need to check your cables, your power, and your physical connections. Moving to the data link, verify switch connectivity, MAC addressing. Layer 3, or the network layer, check IP configuration, routing, and I think you get the point from there. This is often most efficient because lower level problems can cause symptoms that appear to be higher layer issues. And if you flip that and start from a top-down approach, start at the application layer. Check the specific application. From there, you go to your presentation, verify encryption, formatting. And then you move to the session layer, Layer 5. Check your connection establishment. This can be useful when the problem is clearly related to a specific application. Okay, so with all that being said, here's some real-world scenarios to apply some of the troubleshooting methodology and also to see the OSI model in action. Scenario 1. I can't access any websites. First, check if other applications can access the internet. Layer 7. If no applications work, check your IP configuration. Layer 3. If IP is correct, check your physical connection. Layer 1. Scenario 2. This website shows a certificate error. This is likely a presentation layer, Layer 6, issue, with SSL and TLS encryption. Check date and time settings on your computer. Verify the website certificate hasn't expired. Scenario 3. File transfers start but never complete. This could be a session layer 5 issue with maintaining the connection. Might also be a transport layer problem with reliable data delivery. And finally, check for firewall timeouts or network congestion. The Network Plus exam loves to test your understanding of the OSI model. Here are some key tips. Know your acronyms. All people seem to need data processing, layers 7 to 1. And if you don't like it that way, we can always go with the more common, please do not throw sausage pizza away, layers 1 to 7. Protocol placement. Know which protocols operate at which layers. Understand that some protocols span multiple layers. Some problem scenarios. Practice identifying which layer is responsible for different issues. Think about how problems cascade from one layer to another. And finally, PDU names, or protocol data units. This is essentially which layer produces which type of data. Layer 7 to 5 is just data. Layer 4 is segments, TCP or datagrams. Layer 3, packets. Layer 2, frames. Layer 1, bits. While the OSI model is important conceptually, in practice, most networks today use the TCP/IP model, which has 4 layers. Application layer combines OSI layers 7, 6, and 5. Transport layer, same as OSI layer 4. Internet layer, same as OSI layer 3. And the network access layer combines OSI 2 and 1. For the Network Plus exam, know both models, but understand that the OSI model provides more detailed troubleshooting granularity. The OSI model isn't just some theoretical concept to memorize for an exam. It's a powerful mental framework that helps you understand how networks function and provides a systematic approach to troubleshooting. By breaking network communication into 7 distinct layers, what seemed like complex technical voodoo suddenly becomes logical and manageable. Whether you're preparing for the Network Plus exam or you're just trying to understand why your internet isn't working, the OSI model is your roadmap to network clarity. Remember, network professionals don't just memorize the layers. They think in those layers. Start applying this model to your everyday tech interactions, and you'll be surprised how quickly networking concepts begin to make sense. Thanks for watching. If you found this breakdown helpful, hit that subscribe button for more networking concepts explained in plain English.